There's a new offering from Microsoft in the container as a service space, and it's called Azure Container Apps. I'm quite excited about it, and in this video, I'm just like to take a little explore around what's currently there, some of the limitations, and just also the potential of what this can be. Let's take a look. Container apps. It looks and smells very much like container instances. It is a container as a service offering from Microsoft. So the first reaction, if yours is the same as mine, is hang on, why can't we just use container instances? And what makes this slightly different, without trying to delve too much into the details of comparison between the services, is container instances is very good at saying, I've got an image, create a container for me, and run it. Run the container. That's it. Which is exactly what container as a service is, what you'd expect from it. But where it falls short is container apps feels to me like it plays a little bit more into a zoomed out picture where you say, okay, I've got a container, but the container plays within a series of other containers, or you've got multiple ones in a microservice setup or something like that, where you're not just saying, here's a container, run it. Where you're actually saying, all right, here's a container. This one needs to be accessible via this one. That one needs to scale out heavily. This one doesn't. And that kind of control. And as soon as we're talking that kind of control, you immediately want to jump over to Kubernetes services. So container apps sits in between container instances and AKS, where we have some flexibility that you get with Kubernetes, and then actually underneath it runs on Kubernetes cluster. So you've got the same backing, but it's a little bit more managed. It's a Kubernetes AKS is already managed, but this is a more managed version. So you don't care about nodes, you don't care about those things, but you're basically saying, I have a few services. This is what they should look like. This is how they should scale. Run them for me. I don't want to talk Kubernetes. I don't want to orchestrate all of this. Creating one is really simple. So you go into the portal and you find the container app, which is in preview. Just note there are things that don't work very well, but you go to create and you basically need to set up an app environment. We'll look at what environment is now. And then you define, as you'd expect from a container as a service, you need to define your registry. Where do I actually find this Docker image that I can run? And you've got some configuration there. And that's it. Pretty much that's all you need to get up and running. So an environment, if we look at the documentation, is kind of like this isolation boundary. And it's really useful when you have certain containers, or let's talk about apps or services in the world of Kubernetes, which need to interact with each other. So you've got an app 1, app 2, and you might want to expose app 1 to the public, but app 2 references app 1, but it's internal, and you can do that with the environment. As long as they're in the same environment, you can have an ingress, but it's private to that environment. So it provides yourself with a good isolation boundary for multiple services or apps. Then we get the containers. You can kind of look at the container as a service. Within the containers, we have revisions, and this is probably something you would expect when you have, the kind of blue-green deployments. So you create a new revision. You can decide where the traffic goes. You can put 100% traffic immediately to the new revision, or you can put some traffic there. You can do certain testing, So that revision is very similar to deployment in Kubernetes, and within that, it runs a pod. Although it's interesting, it defines a pod here. You don't really have much control of the pod. You're just defining where the image is. It will run it and create it for you. And as I mentioned, it is running in Kubernetes cluster in the background. You just don't have to care about nodes and clusters or anything like that. So yes, your app and your container is running in pods, but within the context of this managed service, pod is really not something that you actually need to care about. So let's see this in action, and you'll see I've got a deploy options repo It's a public repo. You're welcome to take a look at it. And I've got 3 services. Now, these 3 services are really basic, and they're just conceptual, essentially. But we've got our front-end service, and that's Angular. And that points to a web API backend. And then there's a lucky number generator, which is a third service, which is not publicly accessible, but it will be available only to web API. So the idea is that front end talks to web API, and which may sometimes talk to a different service. So if I run Docker Compose up, you'll see we'll create the 3 different services. Front end depends on web API depends on lucky number. Let's jump right into Docker desktop over here, and you'll see it's up and running. I'm not going to dig too deep here, but the important thing to know is the weather forecast gets loaded from the API backend, and then there's another one, lucky number, which goes through the web API backend, but then to another external service, a third service, which is the lucky number service. To deploy this to Azure, I've created GitHub Actions, and basically, let's zoom in here a little bit. We've got the infrastructure, which is basically just Bicep, which creates the workspace for analytics, as well as the environment, which we had a look at documentation. And then I created 3 different applications over here. So we deploy 3 different services, and these are all container apps. And I've used YAML files for them. You can use Bicep. So the infrastructure I set up with Bicep. Then I use YAML files for these. I do feel that's a little bit easier than using Bicep, and it's a little bit more aligned to Kubernetes. I do like that. Once it runs, we've got our environment. Once again, the environment is the isolation boundary, and I've deployed all 3 apps in that environment. And over here, what you'll see is you've got the Angular, the web API, as well as the lucky number app deployed into this environment. Drilling into one of these, let's take a look at the web API. There's not an awful lot you can do in the portal as it stands. And a few things that I feel are still missing. Managed identity, for instance. You can connect to container registry, for instance, through service principals, but not through managed identities as far as I'm aware at the moment. And obviously there are other benefits if you wanted to connect to a key vault, for instance. That is quite valuable to me. But you see revision management over here, and these are the revisions that you create when you deploy an application. So you'll create a new revision, and then the traffic then goes to the new revision, which means now when you hit this, it'll go there. And what you can do is you can go to the application URL over here, and then you can see the application. To take a look at some of the revision details, so once we go into the revision, let's look at the active one. You can take a look at the scale. So we've scaled this out from 0 to 5, and if you do look at the YAML file, for instance, we've got that defined in the YAML, so that matches up there. I have played around with the scaling rules, and the HTTP ones aren't working very well. So even if in the portal, even if I go to the overview and I edit, you create the scaling rule, but it just doesn't show in the portal. So I'm assuming that's going to be fixed soon. But for now, you should be able to scale and add your scaling rules over here. This is obviously a slider. Documentation says you can go up to 25, which is great, better than what this thing allows you to go to only up to 10. But I mean, it's nothing near the scale of Kubernetes. So I'm expecting that will change as well as this thing becomes generally available or publicly available. You'll notice as well, there's on the container app level, there are secrets, so you can configure secrets. In my YAML, I've got a secret over here. You can define those. Ingress is quite important. So this is what I was talking about, which is something that, for instance, container instances doesn't do, is you can have ingress, but you can also then say it's limited to the environment. So it's internal, kind of like a cluster IP in Kubernetes, and then, or is it publicly available, completely available to the public? Now, to note there, when you're talking about containers that need to run, you always have two ports incoming, and obviously the containers port and the port on the node or wherever the incoming port. So this is only defining the target port, which is your Docker file, what your Docker file exposes. And the reason for that is it basically all traffic coming in on this URL that's defined is coming through 443. So that's already just there. So you only need to find the target port of your container. But it's time now to take a look at actually running this from Azure. We've deployed it, and once I go back to the apps, let me go to the front end app, because that's where all the magic really happens. Is the users will navigate to this, and from here they should see the same as what we saw in the Docker Compose. Now, something interesting over here you'll note is, let's just go to today's lucky number, and you'll see that this loads for quite some time, which is really not a great experience. We'll see how long that loads now, but and the reason for that is, I know it's a point that gets marketed on, saying that it can scale down to 0. You know, container as a service kind of says, well, if you're not using it, scale down to 0 pods or 0 replicas. And finally it did load, and you'll see if we now switch back and forth, now it's really quick. But the problem with this is we're actually, when it's on 0 and requests come in, it takes a while to pick that up and then see that it needs to scale, start it up. It's really appealing to say that it scales down to 0 and you don't pay for when it's not in use. But realistically, I can't imagine I would ever set it to 0, at least on the HTTP ingress side where responsiveness matters. You know, user experience is important, as well as, I mean, especially if you have SLOs or something in place, that matters. Where it is really useful to scale back down to 0, is if we take a look at the documentation again, and let's just have a look. Where is that? We go to scaling an app. There are these KEDA scalers, so it does support these, and this is really nice, because now anything that you can do in the Kubernetes scaling, you can use these scaling rules. So you can define if the CPU reaches a certain level, if the memory reaches a certain level. You can work from queues, pretty much any data source over here that you can hook into, and based on those you can define rules to say that, okay, the queue length is so long, therefore scale out. And in these cases it really is nice to be able to say, I have 0 replicas. Like if we look at cron, for instance, that's quite nice if you want to run a daily job. So you've got a container or a service that just runs once a day, and you define a cron expression to run midnight or something like that. And when that thing starts up, only then it creates a replica or scales out to according to your rules. And this is really nice. So you don't pay for when you don't use it. Now that we've got it up and running, I just want to show that making changes is really easy, and that is also something that we expect. So let's say we wanted a number between 1,000 and 9,000 for the lucky number generator. So what we can do is just commit this, make the change, and higher number, and we commit and push. Currently I don't have any policies for POs being required, so I can just push straight to master, and it'll kick off the workflow in GitHub. While that workflow is running, just quickly having a look at, on a high level, what's happening over there. So the first thing is infrastructure. This isn't really important. This is just setting up my the environment as well as the workspace needed for the environment, but we'll get to that through Bicep. The second deployment step is the deployment of the lucky number generator, and ideally, I mean, these are independent services. They'll be in different repos, but for simplicity's sake, they're running in parallel together, only depending on the infrastructure. So what we do there is basically we check out the code, log into Docker Hub, And I know a lot of the examples for container apps talk about container registry and how to set that up. And that is probably a good idea, is that if that's where you're storing your registry. It just costs money, and I'm cheap, so I went for the good old public Docker Hub version. So we connect to that, we build from the Docker file. Once we've built that, we run this, and this basically points to the YAML file that I've defined for that application. And that YAML file, then looking at the number generator, is very similar to what you'd expect maybe with a deployment or a service that you define in Kubernetes. It defines the state of what your app should look like. And over here, you could have within the scale, you can define rules. And from there, what rules do you have? HTTP, the type, or I'm not sure of the exact details. Need to check the documentation there, but offhand. But essentially, that points to which image, how does the ingress look. For instance, the lucky number generator, we do have ingress, but it is not available externally. And as soon as it's deployed, all the traffic runs there. So now if we take a look at the workflow, it should have deployed, and we'll probably see the difference there already. Jumping over, we see the lucky numbers finished. They are running in parallel. I'm not going to necessarily wait for the others. So let's jump over to the application and see if the change has been made. So here we are back at the application. So I hit lucky, just switch out from there because it won't reload it. And now back to lucky number. And this will take a while. Once again, the new revision had scaled down to 0 replicas. It'll also scale down to 0 replicas if you don't use it. And we just need to give it a moment now. It's running through the web API, as well as then the lucky number generator. And there's the change. We see that it has propagated through. We obviously saw that there was loading for a while on the deployment options, loading the number, but we can also have a look at the number of replicas and how that scales out. So I've got a little makeshift script over here, which just queries from the AZ CLI the revisions and checks the replicas. Currently, we've got 1 replica based on the front end that we hit just now. But what we can also do over here is just hit the API pretty hard, and we paste, let this run, and we should in a moment see that the replicas go up. And this is without any specific rules we've defined. So this is the default out of the box HTTP scalers that happen. So we'll just give that a second, and we should start seeing that the number of replicas increase. And we can actually also see that from the apps itself. And the only reason I did the script is it's just a little bit easier to see as it comes in. But once we're over here, we can go to the specific revision, go to that revision. Let's just have a look. Here we go. Now we can see it was 1, 4, 5. So 5 is our max. So it would have, I see when you put the limit higher, it'll go 1, 4, 8. So it would have gone to 8, but 5 is our max. And yeah, so you can see the replicas there. And so we are scaling up, and it is fairly responsive, assuming that you've already got some replicas running and suddenly you've got a lot of requests. Yes, there is going to be a slight delay before we can scale out, but if you get those right, it scales out fairly quickly, and you should be able to handle the load quite nicely. So let's quickly zoom out just to understand what we've done here. So we've created an environment which is a nice isolation boundary for our container apps. Our container apps are essentially 3 services which are independent. They can be independently scaled, independently deployed, and they can interact with each other, even though the access is only within the environment internally. And from this, we can create revisions. So for every update that we have some flexibility around revisions with regards to the traffic and the do certain A/B testing. So that is all out of the box, and we haven't created any clusters, set up any orchestration outside of that within the CI/CD and the actual deployment. within the environment. So we haven't needed to even consider nodes, which is exactly what a container as a service should do. We've never defined where this thing runs. It just runs. And this is really neat because I can essentially focus on my services and what am I running rather than how am I running it. And I think that's the key to remember here. I think in the future we will see more applications being created. And I say in the future because I'm going to get to the pain points now, because we don't need large orchestration setup. We don't need Kubernetes. So what are the points which are not working so well, or the areas where I feel this has fallen short a little bit? And for me, they're quite a handful. And I'll start with the logging. I think the logging is quite poor. So we've got the log analytics workspace, and I think this is wonderful because everything is centered around this log analytics workspace. And we can through it as your monitor, see what's going on and manage our things, query our things. This is wonderful. But I mean, you've got your various applications and it's really hard to even know what's going on. I can't get into the container itself. I can't, it's running Kubernetes, and we've got the infrastructure underneath set up through Kubernetes, AKS, which is managed for us, but we can't do kubectl commands, so we can't get into the container itself. We can't see what's going on. So the only way to actually see, hey, what went wrong, is we've got these custom logs that get written. And I mean, if we're going to run this over here, let's see, for the last 24 hours, all the items are bundled together. It's not very intuitive to figure out what's going on over here. And you're going to have to kind of see, all right, well, this is for which container. Let's have a look, and we see certain containers. So we've got something called container app name. So we'd have to query it like this and say where container app name equals, and then we could say deploy, what is that thing's name, options, let's say web API, and hopefully this would then bring us a slightly more limited result set, which it does, and then we can look through the logs a little bit over here. As I say, the logs are there, the raw stuff is there, it's just not very intuitive. Also, something I had hoped for is when you go to Azure Monitor and you want to view your container insights, you'd expect maybe there's something there. There isn't, unfortunately. So where it's lacking a little bit there, I feel you do have the raw logs. Diagnosing and troubleshooting is painful. It really is. When something goes wrong trying to start the container, it's not easy to figure out what's gone wrong and what to do about it. Another thing that is a bit disappointing, and I did touch on that a little bit earlier, is that we can only scale up to, well, from the portal you can only set it to 10, but 10 replicas. But from the documentation, apparently you can do up to 25. I actually tried through CI/CD, but it still blocked me at 10. So I'm not sure if I'm doing something wrong. But 10 replicas are not a lot, and especially because when we're creating these applications themselves, you need to specify your memory and CPU, and these aren't huge beefy options you get. So I mean, 10 replicas or 25, let's give them Microsoft the benefit of the doubt that you can do 25 somehow at the moment. I'm hoping this increases drastically because I mean, with Kubernetes you can run quite a lot of pods within a node, and you can have tons of nodes. I mean, we're talking about hundreds of thousands of replicas you could run versus 25. It really is, I'm assuming, just limited now for preview use to tinker around a little bit and not for real scale. Talking about CPU and memory usage, this is something else. So if we go to create a new resource, and the reason why I'm checking it here is because you can't actually see or edit the options from the portal otherwise. So we'll go to containers, just create a a new one just to see our options over there. And go to app settings. And over here, what you'll see is, let's choose this. We've got a few options over here. 2 CPU cores with 4 gigs of memory. That's the biggest you can get. But also, they come in pairs. This is a little bit awkward. So if you've got something that doesn't take a lot of processing, but it needs a little bit more memory, you're kind of stuck with taking a higher processor, or vice versa. Something is taking tiny amount of memory, yet more processing. So you're stuck with that kind of ratio. I'm hoping this changes too, and especially as I mentioned, these aren't very powerful. So running replicas as well, you feel like the scaling is really not where I imagine it will be coming down the line. When you define your YAML, you cannot actually do an apply. So what ends up happening is you've got an update, and then you define your YAML over here. So if the application doesn't exist, you have to do a create. And this isn't great. With Kubernetes, you can just apply your YAML, and it'll create it if it's not there. It'll update if it is there. It's a small thing. It is a little bit annoying. I had also expected that from the Azure side that you would be able to run your custom domains. So there's nothing like that over here. So currently you're kind of stuck with this domain, which is not great either. So it really isn't production ready, I feel. I'm assuming this is going to come along the line, as well as with manage identity and being able to see this container app that you're running as a managed identity, which you can give access to certain things within your Azure resources.